To graph the parabola 4x squared minus 8x, remember we changed this one in class, so make sure that you're factoring the right thing. We're going to consider all of the important points that it has, including its x-intercepts, its y-intercept, and its vertex. Let's start with the x-intercepts. To find the x-intercepts, which implies that the y-coordinate is always 0, we can plug the y-coordinate in as 0 and work with what we've got. The equation would then say 0 equals 4x squared minus 8x. In terms of the way this is set up, you would probably want to consider the easiest method of factoring. I would try, for example, taking out a common factor, since 4x squared and 8x do have something in common. Their common factor is 4x. So if I factor out a 4x, that would leave me with x minus 2, which now is still equal to 0, but is much easier to solve. We can use the zero product property, and we can take x minus 2 equals 0. That's one of our factors. We can also take 4x equals 0. Remember, anywhere there's an x, it gets equal to 0. If I solve the first one, 4x equals 0, by dividing 4 on both sides, we get x is 0. So that means one of my x-intercepts must be 0 for x, and of course 0 for y, since that's what an x-intercept looks like. If I solve the second one by adding 2 to both sides, I would get x is positive 2. So that means the coordinate of my other root must be 2, 0. In terms of my graph, that means I certainly have points at 0, 0, and 2, 0, which will help me get the ball rolling when it comes to actually making my sketch. Now, if you remember the logic that we used, the x-intercepts occur when the y-coordinate is 0. So by the same logic, the y-intercept must occur when the x-coordinate is 0. So if I go back to my original equation, I could plug in 0 for the x's, and that's probably the most efficient way of getting the y's. So if I solve y equals 4 times 0 squared minus 8 times 0, 0 squared is 0 times 4 is 0. Minus 8 times 0 is 0, and 0 minus 0 is, of course, 0. So that means the y-intercept must be 0, 0, which totally makes sense because when we go back to our graph, you can tell that this original point that we plotted for the x-intercept also happens to touch the y-axis, so it kind of logically goes that that would be the same intercept for both. Now, in terms of finding the vertex, there are a couple of different ways you can do this. One way you could always use is by using your calculator. There is nothing wrong with plugging in 4x squared minus 8x into your calculator and using the table, the trace function, or any of the other functions you're used to, and identifying the coordinates of the vertex that way. If you wanted to do it algebraically, you would use the process of what we call completing the square. We would start, of course, by thinking about the original equation, 4x squared minus 8x. Since we always want our graphing form, remember that's the a parentheses x minus h squared plus k, the graphing form is the one that we always need to use in order to read the coordinates of the vertex. So we have to think about which of those parts that we can identify. We know that there's a 4 in front of the x squared, which means that 4 must be the a value. I'm going to pull that a value out of the original equation, leaving me with x squared minus 2x. Now we can use the process of completing the square, which will help us work with getting this equation, which isn't very useful, into the vertex or graphing form, where we can actually tell what its coordinates will be. To do completing the square, remember we use the process of dividing by 2 and squaring. I'm going to focus on the number inside here next to the x, which is the 2. 2 divided by 2 is 1. 1 squared is 1. So by using completing the square, I know what number I need to add into the parentheses. That number times the outside number needs to balance the equation, because essentially I just threw the equation off a little bit. I added 1, and the number 4 outside says, well, hey, you really multiplied this times 4. You really added 4 to this side of the equation. So I need to add 4 to the left-hand side to balance it out. That means on the left-hand side, I'd have y plus 4. They're not like terms, so we just kind of roll with it. And then we have the 4 outside parentheses. And now this inside thing, x squared minus 2x plus 1, that's a trinomial. That's just a diamond problem. We need numbers that multiply to 1 and add to negative 2, which is really negative 1 and negative 1. Instead of writing x minus 1, we'd write it as x minus 1 squared. Now you'll notice, of course, that by doing it this way, we can now almost tell what the vertex is. The only step that we would have to go through with is moving this +4 back over to the right-hand side. We've essentially killed two birds with one stone here, as they say, because we now know our equation in graphing form. The equation is going to be y equals 4 parentheses x minus 1 squared and then minus 4. By using the equation in graphing form, we can tell that the vertex is +1, -4. If I plot that point, +1, -4, you can tell that that gives us a pretty logical shape to our parabola. We can tell, of course, by sketching it in, and usually we sketch lightly at first, and then you can darken it in once you kind of got the general outline of it. It makes sense that this is an upwards facing parabola because, of course, the +4 is our a value. It makes sense that it's kind of a narrow parabola because 4, of course, is our a value, and that makes it 4/1, kind of a stretched slope. And, of course, our vertex seems to be right in between the two roots that we already knew. Now, in terms of domain and range, the domain of this function never stops going to the left, never stops going to the right. So in that case, our domain is all real numbers. The range of this function includes its y values. This function definitely doesn't continue on downwards forever. It seems to bottom out at this bottom point here. The y value of that lowest point is -4, because we know that's the y-coordinate of the vertex. So we say this function has a range of everything greater than -4, because the function follows all the numbers greater than that all the way up to infinity, since it never stops heading upwards. To write that, we simply say the y values that are greater than or equal to -4.